Well, I'd like to quickly explain here how the user is free to manipulate some operational aspects, some geometrical aspects of the mine by just changing some parameters. And beforehand, just mention that SimChat could be also called by command line, and it works with XML files. So if we have an advanced user, or if you wanna integrate SimChat within another platform, you can just call your own script that will build this XML file and run SimChat. Okay, and one of these parameters are obviously the slope angles, that you can have a different slope angle for each block, so you can build any rosette or anything you want by just manipulating the slope angles, and you can have different setups of slope angles and run many cases to see the impact of changing some geotechnical aspects to measure, for example, if you want to invest more on geotechnical things, to see if this will bring more value to your project or not, if this is worthy investing or not. These are just examples. And SimChat work with surfaces, so the geotechnical part is very well addressed without approximation errors. Another point is we have the operational parameters like the bottom widths, the mining widths, that we are respecting using the surfaces. We have a vertical advance rates, and all of this is respected during the optimization. It's done all at the same time, so the user can also play with those parameters and see, because once you change a constraint like that, the optimizer will look for best maximizing the net present value of the project, given that you have forced certain parameters. So obviously you can play with reducing the bottom widths, the mining widths. This supposedly will bring a higher value to your project, so you have to see how much you can win by working with smaller areas, for example, or the opposite. You can test different fleets with different sizing, that you need some certain parameters that could be different. And once again, you can build your own script to play with those set of parameters and see in a cloud of potential solutions what could make more sense to your project. So there's a part of bottom widths, mining widths, that we have like a discretization into points. We have the opportunity to use surfaces to limit and restrict mining. And something that we could use once you manipulate surfaces, you could do it manually using Excel, or you could do this using your own software for doing the manipulations you think are useful for you. And you can manipulate this set of points and import back as a grid. And this could be useful for doing some operational aspects that you think the solution of SimChat was not good as you would expect, geometrically speaking. So you can forbid some areas to be mined. You don't think you're going to have, for example, you don't have an environmental license for a certain time. Maybe you don't have your mining limits are constrained by a certain aspect of your process, or your availability of equipment to access more distant areas. Or you may want to have an in-pit crusher, so you need to force certain areas to be depleted beforehand, or you need to do some pre-stripping. So all of this are doable just by manipulating surfaces and placing and put again for SimChat to run. If you don't like a certain area that's kind of isolated, you can just forbid, restrict mining that area. So these are all examples that you could do in Excel. You could manipulate in your own software, mining software, or you can even create your own scripts to do the kind of manipulation you think would be useful for you. And I think one specific thing that I suggest you doing is you run once SimChat. Once you're happy with the parameters you're going to use, you have the last surface of the periods, then you can do the pit design with the ramps, and then you can import back that surface to run again SimShed inside those limits, which means when you do the design, sometimes you include more waste, you lose ore, so you change the solution that the optimizer has defined. But if you run again inside this solution, maybe the optimizer will change a few destinations of the blocks, will change a few surfaces of the other periods, and it will maybe improve the value. If you just do the two steps that we traditionally do, we first do a mathematical shadow, and then we start doing faces, and then we start doing periods, but the optimization was done just in the beginning, and afterwards we just have manual manipulations. What we propose here is that you do what you need to do, the design, and then you come back, you run again SimShed inside this design. And I'm telling you, giving you the example using the final surface, but once you run again, you can take an intermediate surface. As for example, you can consider this as a phase. For example, here, period 15 is the last one, so I do the design, I run again, and I get, for example, period 10 as one intermediate phase that I want to work with. So I can draw, design this intermediate surface. I can import back into SimShed this set of surface, the final one, some intermediate one, and what should happen. And I suggest you do this from the bottom up to the top, so that you leave opportunities for the optimizer to change the solutions above your surfaces, given that we know the first periods are the ones that define the biggest part of the NPV of the project. So if you constrain things by the design in the last periods and leave the chance of the optimizer to run again, it could change the destinations, could change the use of the stockpile, it could stockpile some material to reclaim during last periods that you see that you're not finding enough material because of the design. So this is what we call an operational optimization, as we are doing design at the same time we're doing optimization. So that's it. We're here to give you support if you need to understand more details on how to do these specifically. Thank you.